Welcome to Primus Civil Services Academy. I am your CSAT faculty, Sachin Gopanaal. In this video, we will look at the CSAT questions of 2025 paper. So, we have already discussed the reasoning questions. Now, we will discuss quantitative aptitude questions, that is mathematics questions. Okay. Before going to that, let me tell you something about this section in the 2025 paper. In the 2025 paper of CSAT, reasoning section questions, they were more or less easy to moderate level. And quantitative aptitude, that is mathematics question, they were from moderate to difficult level questions. On a whole, when we take the section as a whole, this was the kind of analysis that I could make. Okay. Now we will go to answering the questions directly. Question number 5. Okay, all the question numbers, they reflect version A. All the questions, they have been taken from version A paper. A natural number n is such that it can be expressed as n equals p plus q plus r, where p, q and r are distinct factors of n. How many numbers below 50 have this property? Okay, so now n is such a number which has different factors p, q and r, and each of p, q and r are factors of n, and if you add p, q and r, you must get n. How many such distinct numbers are there that are less than 50? So this question, it is best answered by intuition. How? Now, can you think of any one number which shows this property? It has, let us say, it might have many factors, but 3 of those factors, if you add them, they should give you the original number. Yes, by intuition, we know that 6 satisfies this property. 6 is equal to 1 plus 2 plus 3. 6 equals 1 plus 2 plus 3. Okay. Now, this one was easy. Now, 1, 2 and 3, each of the numbers are factors of 6, and together they make up 6. But which other numbers might be there? And up to 50. So, it would be very tedious. But if you just double this equation, that is, if you multiply both LHS and RHS by 2, we will get 12 is equal to 2 plus 4 plus 6. Again, 2, 4 and 6, they are all factors of 12, and they together make up 12. Again, 18 satisfies the same property. 3 plus 6 plus 9. That is, 6 and all its multiples, they satisfy this property. So, how many multiples does the 6 have that are less than 50? 6 8s are 48. So, there are 8 multiples of 6, including itself, that satisfy this property. So, the answer to this question would be option C, 8. Okay, we'll go further now. Okay, 6th question. 3 prime numbers p, q and r, each less than 20, are such that p minus q is equal to q minus r. How many distinct possible values can we get for p plus q plus r? Okay, p, q and r, they are prime numbers less than 20, such that the difference between 2 prime numbers is equal to the difference between another 2 prime numbers. So, to answer this question, let us make a little list of all the prime numbers less than 20. So, the 2, 3, 5, 7, 11, 13, 17 and 19. Okay, these are all the prime numbers that are less than 20. Now, which prime number satisfy this thing? One would be, if you look at 3, the difference between 3 and 2 is 1, but the difference between 3 and another number to be 1 is 4, but 4 is not a prime number. So, 3, we cannot, 2 does not give us any this thing. Okay, what I am doing is, I am looking for Q's here, because if there is a prime number which has 2 numbers on either sides of it, not immediately either side, just to the left of it and to the right of it, where the difference is same, that will give us those sets of numbers. So, 2, there is no number before 2, so it is gone. 3, again, the difference between 3 and 2 is 1, but there is no other prime number which has a 1 difference with 4, so 3 is left out. What about 5? Yes, 5 satisfies this property. 5 minus 3 is equal to 7 minus 5. Then, what about 5 and 2? 5 minus 2 would be 3, but 5 plus 3 would be 8. 8 is not this thing. So, we are done with 5. 5 gives us only one set of such numbers. Okay, what is the, they are asking us not for how many sets we have, they are asking us for P plus Q plus R. So here P plus Q plus R would be 3 plus 5 plus 7. So 3 plus 5 plus 7, that would be 15. Okay, now let us talk about 7. Now 7 difference with 5 is 3. Sorry, 7 minus 5 is 2. 7 plus 2 would be 9. 9 is not there. So 7 minus 3 is 4. 7 plus 4 is 11. So that we get another set here. 7 minus 3 is equal to 11 minus 7. So what is the difference here? Sorry, what is the sum of these things here? 7 plus 3 plus 11 will give us 21. Okay, then 7, 5, 7, 3, 7, 2. Oh, 7, 2 will give us 5, but 7 plus 4 will be 12. 12 is not there. So we are done with 7. Now 11. 11 minus 7 is this thing. 11 minus 7 is 4, but 11 plus 4 will be 15. No. 11 plus 5 is 6. 11 plus 6, 7. 11 minus 6 is 5. 11 plus 6, 17. So 11 minus 5 is equal to 17 minus 11. Here, what is the sum of the factors? So the prime numbers. 5 plus 11 would be 16. 16 plus 17 would be 33. Okay. And 11, 5. 11, the difference between 11 and 3 is 8, and 11 and 19 is also 8. So 11 minus 3 is equal to 19 minus 11. What is the sum of the prime numbers here? 19 plus 11 is 30. 30 plus 3 is 33. Okay. So we are done with 11 now. What about 13? 13 has a difference of 17. 13 has a difference of 4 with 17, and 13 has a difference of 4 nowhere else. 13 has a difference of 6 with 19, and 13 has a difference of 6 with 7. So 13 minus 7 is equal to 19 minus 13. Okay. What is the sum of prime factors? 13 plus 7 is 20. 20 plus 19 is 39. Okay. We are done with 13. What about 17? 17, the difference is 2, and here you should have been 15. There is no 15. So 17 is ruled out and 19 is ruled out. So these are all the values of P plus Q plus R that we can get. 15, 21, 33, 33, 39. So 33 is divided, sorry, it is repeated. So we need not to count them twice. So together we will count it as 1. So 1, 2, 3, 4. So there are 4 distinct values of P plus Q plus R. So the answer to this question is option A, 4. However, they have not told us that P, Q and R are distinct prime numbers. They have only merely told us 3 prime numbers. They have not told us that, they have not used the phrase distinct. The 3 distinct prime numbers P, Q and R each less than 20. No, that is not mentioned here. So when that is not mentioned here, what happens is, there is a possibility that P is equal to Q is equal to R. Then P minus Q would also be equal to Q minus R. So then all of these 1, 2, 3, 4, 5, 6, 7, 8 prime numbers, they will satisfy this condition, because 2 minus 2 is equal to 2 minus 2. 3 minus 3 is equal to 3 minus 3, and so on up till until 19 minus 9 is equal to 19 minus 19. Since they have not told us that P, Q and R are distinct, so this is a possibility. Why this is a possibility is because whenever they frame such questions, they have seen to it that you have used correct words like distinct, non-negative, positive. They have used the wordings properly in all the other questions. So here I think they have framed the question wrong. So I think as per them the answer is option A4, but if we can also interpret it as the other way, the way we interpret it, that they have not asked us to distinguish between P, Q and R. Then this also satisfies, though then the answer would be more than 6. Okay, option, because 4 plus 8 would be 14. So, but I don't think that they framed the question with option D as in their mind. They framed the question with option A in their mind. So the correct is option A4, but I am merely telling us that we can interpret in another way and give the answer as D also. So there has been a mistake while framing the question. Okay, we'll go to the next question now. Question 7. How many possible values of P plus Q plus R are there satisfying 1 by P plus 1 by Q plus 1 by R is equal to 1, where P, Q and R are natural numbers, not necessarily distinct? Okay. So you see, while they have framed the questions, they mention this distinct, not necessarily distinct. They usually mention such important things, but in the previous question, I think they have just ignored, they have just forgotten to add it. Okay, now let us answer this question. 1 by p plus 1 by q plus 1 by r is equal to 1. Not necessarily distinct. So how many fractions are there less than 1, which when you add up give you the sum of 1? Now this question is easily answered using intuition. How? Now 1 by 2 plus 1 by 4 plus 1 by 4, this will give us 1. Okay. Then 1 by 3 plus 1 by 3 plus 1 by 3, this will also give us 1. Is there any other possibility? Yes, there is one more other possibility. 1 by 2 plus 1 by 3 plus 1 by 6. This will also give us 1. How? Because 1 by 3 plus 1 by 6, this will be 2 by 3 plus 1 by 6, that is 3 by 6. So the 1 plus 1 by 3 plus 1 by 6, this is effectively nothing but 1 by 2. So 1 by 2 plus 1 by 2 will give us 1. So these are all the possibilities that can give us the value of 1. So how many distinct possible values of p plus q plus r are there? Here 2 plus 4 plus 4 is 2 plus 4 plus 4 is 10. Here 3 plus 3 plus 3 is 9. And here 2 plus 3 plus 6 is 11. So all of them are distinct. So how many different possible values of p plus q plus r we have? We have 3 different possibilities. So the answer to this question is option C, 3. But if you want to answer this question, okay, I told you that this is only, we can answer this directly using intuition. But if you want to go deeper into it, if you want to prove it mathematically, we can do it. I will show you how. Now, let us assume that, just for our consideration, P is less than or equal to, Q is less than or equal to R, just for our convenience. Okay, if that is the case, then 1 by P will be greater than or equal to 1 by Q, which will be greater than or equal to 1 by R, because as the number increases, when it goes to denominator, the value will decrease. So if P is less, then 1 by P will be more. Okay, then we want such numbers which will give us the value of, which will give you the sum of 1. So 1 by P plus 1 by P on Q plus 1 by R, it has to give us 1. Now we know that 1 by P is greater than 1 by Q is greater than 1 by R. So what is the greatest value that R can have? The greatest value that R can have is P. The greatest value, 1 by R. The greatest value that 1 by R can have is 1 by P. So because 1 by R cannot be greater than 1 by Q and 1 by Q cannot be greater than 1 by P, but they can be equal. So the greatest value of 1 by R is 1 by P. So let us see what happens then. Now if 1 by R, now the greatest value that 1 by R can have is 1 by P, and the greatest value that 1 by Q can have, that is also 1 by P. So so this thing 1 by P plus 1 by Q plus 1 by R, it has to be less than or equal to 1 by P plus 1 by P plus 1 by P, because Q and R, they can be lesser than 1 by P, but not lesser than or equal to 1 by P, but not more than 1 by P. So this is this thing. But we know that 1 by P plus 1 by Q 1 by R, it is nothing but 1. So 1 is less than or equal to 1 by P plus 1 by P plus 1 by P will give us 3 by P. And if we send this P this way, P is less than or equal to 3. That is the least number, it is less than or equal to 3. Now how many possible values can P have? P can have 1, 2 or 3 as per this relation. But P cannot be 1, because if we put 1 here, 1 by 1 will already give us 1. Then there is no place for 1 by Q plus 1 by R to make up a 1. So P cannot be 1. P can only be 2 or 3. Okay. So now let us take both the cases into consideration. P is equal to 2 and P is equal to 3. Then continue the proof. Okay. I will wipe this off. Okay. First we will take the case of P is equal to 2. Let us say P equals 2. This is case 1. When P is equal to 2, this will become what? This will become this is 1 by 2 plus 1 by q plus 1 by r is equal to 1. So this is already half. So that means these two they should make up half. That is 1 by q plus 1 by r, they have to make up 1 by 2. Okay. Now once again, the greatest value that 1 by r can have is 1 by q, not greater than that. So 1 by q plus 1 by r, it has to be less than or equal to 1 by q plus 1 by q, because the greatest value that 1 by r can have is 1 by q. So, but we know that 1 by q plus 1 by r is nothing but 1 by 2 already. So 1 by 2 is less than or equal to 1 by q plus 1 by q will give us 2 by q. If you send the q this way, q has to be less than or equal to 4. We send q here and 2 here. Q should be less than or equal to 4. Again, q cannot be 1 for the same reason that p cannot be 1. So there are we have three conditions again. See sub cases. Q can be 2, 3 or 4. Now q cannot be 2 because we have taken that p is 2. We have 1 by 2, and if q also becomes 1 by 2, there is no place for 1 by r at all. These two together they will make up 1. So this thing is gone. So q can have two values. Q can have two values. I will further show you. Now when q can be 3 or q can be 4, so 1 by 3 plus 1 by r is 1 by 2, or 1 by 4 plus 1 by r is equal to 1 by 2. Now this will become what? 1 by r is equal to 1 by 2 minus 1 by 3, which is 1 by 6. Okay. So again this will become 1 by r is equal to 1 by 2 minus 1 by 4, which is 1 by 4. So we have how many cases? First cases I will write it here for 2, 3 and 2, 3 and 6, or 2, 4 and 4. Okay. So PQ here we have two sets of value when p is equal to 2. So these are all the possibilities when p is equal to 2. What about the other case, that is p is equal to 3? If p is equal to 3, then this will become 1 by 3 plus 1 by q plus 1 by r, it is equal to 1. Again we will use the same method. 1 by q plus 1 by r, it has to be equal to 2 by 3, because if this is 1 by 3, together they have to make up 2 by 3, because 1 by 3 plus 2 by 3 will give you 1. So together these two have to make up 2 by 3. Now once again, the greatest value that 1 by r can have is 1 by q. So 1 plus q plus 1 by r, it has to be less than or equal to 1 by q plus 1 by q. So we know that this is 2 by 3. So 2 by 3 has to be less than or equal to 2 by q. So we can cancel out 2 and 2. Q will go this way and 3 will go this way. So we will have q less than or equal to 3. Again q cannot be 1. So q can be 2 or 3. Okay, q can be 2 or 3. Now, okay, I will try to fit the calculations here. I have very little space. Now if q is equal to 2, then 1 by 2 plus 1 by r is equal to 2 by 3. So 1 by r will be 2 by 3 minus 1 by 2. This will give us, this will be 4 by 6 minus 3 by 6. This will give us 1 by 6. Okay. So we have, when this is, when q is 2, so this will give us 3, 2 and 6. Okay. Then when q is 3, 1 by 3 plus 1 by r is equal to 2 by 3. So this is easy. 1 by r is equal to 2 by 3 minus 1 by 3. So 1 by r is equal to 1 by 3. So this will give us 3 and 3. So now we want the value of p plus q plus r. This 2 plus 3 plus 6 and 3 plus 2 plus 6, they are same. They will not give us any distinct values. So we will strike this out. So we have 2, 3, 6, 2, 4, 4, 3, 3, 3. So we have 3 sets of numbers which satisfy the given condition. So 2 plus 3 plus 6 will give us 11. 2 plus 4 plus 4 will give us 10, and 3 plus 3 plus 3 will give us 9. So we have 3 distinct values of 4, 9, 10 and 11. So the answer to this question is again option C, 3. Okay, we'll go further now. Team X scored a total of n runs in 20 overs. Team Y tied the score in 10% less overs. Had Team Y's run rate, that is runs per over, had been 50% higher, the scores would have been tied in 12 overs. How many runs were scored by Team X? Okay, so now how to answer this question? Now Team X scored n runs in 20 overs, but we do not know what is the value of n here. Okay, so but they are asking us, that is what they are asking us n. But here we will keep n as it is. Team Y scored 10% less overs. Oh, no, what is 10% less than 20? 10% less than 20 is 18. Okay, so now Team X scored n in 20 overs, but Team Y scored it in how many overs? 18 overs. So, but what was their run rate? That is runs per over. We will take, let us take it as Y. Because it is Team Y, let us take it as Y. Okay. Now, had Team Y's average run rate been 50% higher, they would have scored it in 12 overs. So now, this is the score, 18 into Y, that is the total score. They could have scored it in 12 overs if their run rate, which is Y, it had been 50% higher. What is 50% higher than Y? It is 3 by 2Y or 150 by 100Y, that nothing but 3 by 2Y. So this is 3 divided by 2Y. So now these are all the equations that you can draw from the given statements. Now 18Y, okay, let us exclude this 9, we will concentrate on this equation. 2 6s are 12 and 6 into 3 is 18Y. So 18Y is equal to 18Y, that is Y is equal to Y. So we cannot find the value of Y. When we cannot find the value of Y, we cannot find the value of n also. So this question cannot be answered. So the answer to this question is option D, cannot be determined. Okay, we'll go further now. The price P of a commodity is first increased by K% and then decreased by K%, again increased by K% and again decreased by K%. If the new price is Q, then what is the relationship between P and Q? Okay, now price P, it is first increased by K%. Okay, so what happens when you increase it by K%? This will be 100 plus K divided by 100. Okay. Decreased by K%, that will be 100 minus K divided by 100. And again increased by K%, so this will again become 100 plus K divided by 100. And 100 again decreased by K, 1 minus 100. And they are telling us that this is nothing but Q. Okay, take a note at the equation. Okay, now this term and this term are common, and this term and this term are common. So P into 100 plus K whole square divided by 100 square. I just multiplied these two terms. Now I will multiply these two terms. Okay, here this will be 100 minus K whole square divided by 100 square. This will be Q. Okay, now what is 100 square? 100 square is nothing but 10 to the power of 4. So 100 plus K whole square into 100 minus K whole square divided by, this is 10 to the power of 4, this is 10 to the power of 4. Together they will give us 10 to the power of 8, that is equal to Q. Okay, now look here, this is A plus B whole square and this is A minus B whole square. We can take squares common, that is A plus B into A minus B whole square. Then what is A plus B into A minus B? It is A square minus B square. So that will become 100 square minus K square whole square divided by 10 to the power of 8 is equal to Q. Okay, do we have any relation showing this one? Yes, the first one, 100 square they have written it as 10 to the power of 4. P into 10 to the power of 4 minus K square whole square is equal to Q into 10 to the power of 8. So this is what is given in option A. So the answer to this question will be option A. Okay, we'll go further now. Okay. This question is, it is actually a question of reasoning. It has been it has been wrongly given here. It is okay. There has been, in CSAT it is hard to distinguish between maths and reasoning. Okay. A solid cube is painted yellow on all its faces. Okay. There is a cube. It has been painted yellow on all its sides. Or which cube are they talking about? The geometrical cube. For example, your Rubik's cube is a cube. The toy that children play, Rubik's cube, that is a toy. That is a cube. A solid cube is painted yellow on all its faces. Okay. It is painted yellow on all its faces. The cube is then cut into 60 smaller but equal pieces by making the minimum number of cuts. Okay. Now, they have cut the cube into 60 pieces. Which of the following statements is/are correct? Now, how to answer this question? Now, you want how many smaller pieces? 60 pieces is what you want. If you, whenever you make one cut, it will give you, it will double the number of, okay, not double. It will give you one extra this thing. For what I am saying is, take a cube, make a single cut on it on any side, then it will give you 2 pieces. If you made 2 cuts on it on the same side, it will give you 3 pieces. If you made 3 cuts, it will give you 4 pieces. For example, again going back to the Rubik's cube. Rubik's cube, on one side it has how many cuts? On each side it has 2 cuts. So it will give you 3 rows or 3 columns. So that way, if you want 60 these things, 60 smaller pieces. Now 60 is given by 3 into 4 into 5. 3 4s are 12, 12 5s are 60. So if in a cube there are 3 smaller cubes, smaller, what shall I say, smaller segments on one side, and 4 smaller segments in another direction, and 5 smaller segments in another direction. For example, like this. This is a cube. Okay. This is a cube. Now I have cut this into, I have made 3 cuts on this side. When I make 3 cuts, I get 4 segments. Okay, and let me make 2 cuts this way. When I made 2 cuts this way, I get 3 segments. Okay, and on the top side, I will make 4 cuts. Sorry, no, this is not that way. X, Y, Z. Okay. This way. So when I make this, what happens is, here I will get, when I make 4 cuts, I will get 5 segments. So how many little cubes will be there inside this? They will be 3 into 4 into 5. Okay. So 3 into 4 into 5, that is, I will get 60 this thing smaller cubes here. Okay. Once again, if you do not understand it, it is better to you watch some video or watch any notes or refer to any notes on cubes. Again, this is just PYQ, sorry, so I cannot explain everything in detail, but I will give you a brief understanding here. So if there are 3 segments on one side, 4 on another side, and 5 on another side, that will give us totally 60 pieces. But to get 3 segments, we need to make only 2 cuts. And to get 4 segments, we need to make only 3 cuts. And to get 5 segments, we need to make only 4 cuts. So how many cuts do we need to make totally? We need to make totally 9 cuts. Okay. Now we got an understanding of this. Let us try to evaluate the statements given. The minimum number of cuts is 9. Yes, we have just proved it. So statement 1 is correct. Statement 2. The number of smaller pieces which are not painted on any face is 6. Now which of the smaller cubes will have paint on them? Now all the cubes which have exposure to the outer surface, they will have paint on them. Only those smaller cubes which are not exposed to outside, they will not have any paint on them. In this context, how many such smaller cubes are there which are not exposed outside? What we need to do is, in each segment, exclude 2 of them, because we told you that here there are 5 segments. One of the segment is exposed to that way, another is exposed this way. And when we are talking about this direction, here we have 4 segments. Again, one is exposed this way and another is exposed this way. And in another direction, we need to think in 3 dimensions, x, y and z. So in each of these things, how many cubes, smaller cubes will be there which are not exposed? Minus 2, 3 minus 2, 4 minus 2 and 5 minus 2. So 3 minus 2 will give us 1, 4 minus 2 will give us 2 and 5 minus 2 will give us 3. So inside, that is excluding the outer smaller cubes, the cubes inside, that is 2 into 3, that is only 6 smaller cubes will not have any paint on them. Do we have that option? So does the statement say this? Yes, it says exactly the same. So the answer to this question will be option C, both 1 and 2. Okay, we shall go further now. Okay, question 17. The petrol price shot up by 10% as a result of hike in crude oil prices. Okay, the price of petrol before the hike was 90 rupees per liter. A person travels 2200 km every month and his car gives a mileage of 16 km per liter. By how many kilometers should he reduce his travel if he wants to maintain his expenditure the previous level? Now, what was his expenditure previously? His expenditure previously was, now he traveled 2200 kilometers, and how many liters of this thing did he spend? He spent this many, sorry. If he traveled 2200 km and his this thing gave 16 km per liter, so the 2200 divided by 16, this is how many liters of petrol he spent, and what is the price of petrol? That is 90. So this is his total expenditure, 2200 kilometers. For every 16 kilometers he needs one liter of petrol. So 2200 divided by 16, that is how many liters of petrol he wants. We need not calculate that, we need not do the calculation right now. Okay, and each of each of liter will cost him 90 rupees. Now he needs to reduce his travel. So when he needs to reduce his travel, we do not know how much distance he will travel. So let us say that he travels only X kilometers now. But what is his mileage? His mileage does not change. His vehicle will still give him 16 kilometers per liter, this thing. But there has been a hike in the price of the petrol. What is the 10% more than 90? It is 99. How? Because 10% of 90 is 9. So 10% more is 90 plus 9, that is 99. Now, if you do this, his expenditure will remain same. So now if you calculate for X, then we will get what is the reduction in his distance. Here we can cancel out 16 and 16. 9 divides both of them. 9 10s are 90 and 9 11s are 19. 11 divides 22. So 11 2s are 22 and add 2 zeros here. And 200 into 10 will give you 2000. So now he needs to travel only 2000 kilometers. Earlier he used to travel 2200. Now he can travel only 2000 to keep his budget constant. Now, so how many kilometers of reduction did he make? He made a reduction of 200 kilometers. Do we have that option? Yes, option B, 200 is our answer. We'll go to the next question now. Question number 8. A 4-digit number n is such that when divided by 3, 5, 6, 9 leaves a remainder of 1, 3, 4, 7 respectively. What is the smallest value of n? Okay. Now, when they tell us that there is a number, it is 4 digit, and when it is divided by 3, it leaves you a remainder of 1. It means that that number is 1 more than a multiple of 3. And when they say us that there is a number which when divided by 5 leaves a remainder of 3, it means that that number is 3 more than a multiple of 5. Correct. For example, take 25. 25 is a multiple of 5. But 28, that is 3 more than 25. When you divide 28 by 5, it will give you a remainder of 3. So, out of these things, which number will give us a multiple of 5 when it is subtracted by 3? Only these two, 1068 and 1078. Because option B will give us 1069, that is not divisible by 5. This one will give us 1079, that is also not divisible by 5. So option A and option C, we have two options now. Now this will give us what? 1065, and this will give us 1075. These are divisible by 5. Okay. Now let us evaluate the condition for 3. Now, if you reduce this by 1, you should get a multiple of 3. What is 1 less than 1068? It is 1067. Is 1067 divisible by 3? No, because 1 plus 6 plus 7 will give us 14, and which is not divisible by 3. So 1067 is not divisible by 3. Let us try 1077. Why 1077? Because 3 leaves a remainder of 1. So is 1077 divisible by 3? Yes. 7 plus 1 is 15, which is divisible by 3. So option C satisfies the condition for 3 and 5. We need not check other options, and we need not check 6 and 9. We can directly mark option C, 1078 as our answer. Okay, we'll go to the next question now. Question number 20. Okay, now what is the unit digit in the multiplication of 1 into 3 into 5 into 7 into 9 until 99? So they have multiplied all the odd numbers starting from 1 to 999. Now what comes at the unit digit? What is the last digit of such a number? Now we need not think too much about it. Here we have a 5, right? Here when we have a 5, this whole number, it should be a multiple of 5. So it should be a multiple of 5. What is the divisibility rule of 5? It says that the last digit of the number should be either 5 or 0. Okay. Do we have a 0 here? No. Do we have a 5 here? Yes. So option C is our answer. And it cannot be 0 because we needed at least one even number to make a 0. There is no even number factor here. So our answer will be option C, 5. Okay. We'll go to the next question now. Question 25. Okay. Now consider the first 100 natural numbers. How many of them are not divisible by any of 2, 3, 5, 7 and 9? So, okay, how to answer this question? Now, if there is a number which is less than 100 and it is not divisible by 2, 3, 5, 7, 9, it has to be a prime number. Okay, and all the numbers that satisfy this condition, they have to be prime number, because 7, the next prime number after 7 is 11. So 7 into 11 is 77, and 11 into 33 is 11 square would be 121. So we need to check till less than 100, so less than 10. So all the prime numbers that are less than 10, if a number is not divisible by less than if a number that is less than 100 is not divisible by any prime number less than 10, then that number will satisfy this condition. So how many prime numbers do we have less than 100? They are, we can just write them down: 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, then 83, 89 and 97. Okay, so these are the 25 prime numbers less than 100. Now 2, 3, 5, 7 are gone. Okay, so how many numbers are we left with? These many numbers are we left with. But okay, so how many prime numbers are we left with here? We are left with 21 prime numbers. Okay, but look at the question again. It asks us for first 100 natural numbers. So when they say 100 natural numbers, we also need to consider 1, because 1 is a natural number and it is not divisible by any of these numbers. So 21 plus 1 will give us 22. So the answer to this question will be option C, 22. Okay, next question. 26. If 4 is greater than or equal to, 4 is less than or equal to x is less than or equal to 8, and 2 is less than or equal to y is less than or equal to 7, then what is the ratio of the maximum value of x plus y to the minimum value of x minus y? Okay. Now, what is the maximum value of x plus y? The greatest value of x is 8 and the greatest value of y is 7. So, the greatest value of x plus y, it has to be 15. 8 plus 7 will be 15. Now, what is the minimum value of x minus y? To get minimum value for x minus y, we need to make x smallest and y greatest, because x minus y. So, what is smallest value of x? That is 4. And what is the greatest value of y? It is 7. So, 4 minus 7 will give us minus 3. Okay. So, what is the ratio of the maximum value of x plus y and minimum value of x minus y? That will be 15 divided by minus 3, and it is nothing but minus 5. Do we have that option? No. So, the answer to this question is D, none of these. Okay, we will go further now. Let p and k be prime numbers such that p square plus k is also a prime number less than 30. Then what is the number of possible values of k? Okay. Okay. Now, p and k, they are prime numbers, and their sum p square plus k, that is also prime number less than 30. Now, how many prime numbers are there less than 30? We will just list them. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. Okay. These are all the these things of these are all the prime numbers less than 30. Now, 2 square plus 3 will give us 5. Okay. So, okay, this is one such pair. Okay. Next, if we reverse it, 3 square plus 2, that will also give us 11. So, we have another such pair. Okay. And one more thing, if you all such cases, they have to include 2 in those relations. Why? Because if you did 5 square plus 7, or if you did 3 square plus 5, what happens is 3 square is the square of 3 would be odd number and 5 would be odd number. So, when you add 2 odd numbers, you will get an even number which cannot be prime. So, if you want prime, then this such relation, it has to include 2 either here or 2 here. So, you need to check this 2 square plus 3, 3 square plus 2, then 2 square plus 5, 5 square plus 2, 2 square plus 7, 7 square plus 2. You need not check the relationship between the rest of them. So, what is 2 square plus 5? It is 9. 9 is not a prime number. What is 5 square plus 2? That is 12. So, 12 is, 5 square plus 2 will give us 27. That is not a this thing, prime number. What is 2 square plus 7? 2 square plus 7 will give us 11. Okay. Then what is the 7 square plus 2? This is 51, which is more than our required this thing. So, what is a 2 square plus 13? 2 square plus 13 will give us 17, which is less than this thing. Then 13 square plus 2, no. 2 square plus 17 will give us 21, not a prime number. 2 square plus 19 will give us 23, which is less than 30. Then 2 square plus 23 will give us 27, not a prime number. 2 square plus 29, it is greater than this thing and not a prime number also. So, how many k values do we have? 3, 2, 7, 13, 9. All of them are distinct. This is p square plus, they are not asking us for the how many numbers of p square plus q are there. They are asking us how many number of possible values of k are there. 2, 3, 7, 13, 19, all of them are distinct. So, how many values can k have? Option B, 5. Okay, we will go further now. There are n sets of numbers, each having only 3 positive numbers with LCM equal to 1001 and HCF equal to 1. What is the value of n? Okay. Now, remember one thing, there is 1001, it is one of the favorite numbers of UPSC CSAT. They have been asking questions on based on this number and its properties multiple times, because 1001, it is a multiple of 7, 11 and 13. It is a product of 7, 11 and 13. All are big these things, prime numbers. So 7, 11, 13, they will give you 1000. Remember it. Okay. Now, how many sets of numbers can we make such that, and they all of them, they are prime numbers. So their HCF will be 1. So one set is 7, 11, 13. Then if you send 11 this way and keep 1 here, 77, 1, 13. Again, their LCM is 1001, but their HCF is 1. Or if you send 11 this way, 7, 1, 143. They also have their HCF as 1001, but LCM is 1001, but HCF will be 1 because they do not have any common factor other than 1. And then if we can multiply 7 and 13, that will give us 91, 11 and 1. So again, this is another set. Okay. Now, these are the 4 sets possible using only these numbers. But what if we did like this? Multiply 7 with itself. 49, 11, 13. Again, they do not have any common any common factors. So their HCF will be, not like this. What if we multiply 7 with 11? 77, 11, 13. They do not have any common factor. Yes, 77 and 11 have a common factor, but not with 13. So again, their HCF will be 1, but their LCM will be again 1001. Or if you kept 7 as it is, if you multiplied this thing here, 7 here, this will also have their this thing as HCF as 1, but LCM as 1001. Then if you multiplied 7 here, 7, 11, 91, or if you multiplied 11 here, 7, 11, 132. Okay. All of these cases, they will have their these things as HCF as 1 and LCM as 1001. But there is another possibility. How many sets of number? 1001 itself, then 11, then 7. These will also have its LCM as 1001, and their HCF will be again 1, because all the 3 of them together, you cannot make out any common factor. So how many these things are possible? Actually, you can still go on. 11, 13, 7, 11, 1001, 11, 13. That way we can still go on. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have already listed 9. Look at the options: 6, 7, 8, more than 8. We have already listed 9, and we can still go on. So the answer to this question is more than 8. Option D is our answer. Okay, we'll go further now. Question 29. Let PQR be a 3-digit number. Okay. PPT be a 3-digit number and PS be a 2-digit number, where PQ, R, S and T are distinct non-zero digits. Further, PQR minus PS is equal to PPT. If Q is equal to 3 and T is less than 6, then what is the possible number of values of R and S? Okay. So let us express these numbers in decimal system, in either proper values as per decimal system. Now PQR, it is nothing but 100P plus 10Q plus R, but they have already told us that Q is 3. So PQR will be nothing but 100P plus 30 plus R minus PS is 10P plus S. So this will be minus 10P minus S is equal to PPT. Now this is 100P plus 10P, that is 110P, 110P plus T, 110P plus T. Now T is less than 6. So when they tell us T is less than 6, T can have these many values: 1, 2, 3, 4 and 5, but they have also told us that they are distinct. So 3 is ruled out because Q is 3. Now T can have 4 values: 1, 2, 4 and 5. Let us evaluate each of them. Okay. Now let T be equal to 1. We are evaluating this case. When t is equal to 1, what happens is 100. So let us solve p first. Let us make it simpler. Let us simplify this equation before going further. If we can take 10p this, we can take this 10p, 110p this way. That will be 100p minus 10p minus 110p plus 30 plus r minus s will be t. Okay. So what is this? This is minus 20p. So minus 20p plus 30 plus r minus s is equal to t. Since we are looking for the values of r and s, we will keep them on one side and send the rest of the terms the other way. Is equal to t plus 20p plus minus 30 minus 30. Okay. Now let us take all these values for t. Now let t be equal to 1. This is case number 1. When t is equal to 1, r minus s is equal to 20p minus 29. Because t is 1, then minus 30 plus 1 will give us 20p minus 29. So what can the value of p be? See that r and s, they are individual digits. So p can only be 1, because when p is 1, we will get 20 minus 29, that is minus 9. That is a possible difference between two integers. But if p is a 2 or anything more than 2, what happens is this value will be 40. 20 into 2 is 40. 40 minus 29 will be 11. The difference between two integers, it cannot be 11. The maximum difference between any two digits is 9 and 0. So if we take p as 1, then 20 minus 29 will be minus 9. But for two digits to be the difference between two digits to be 9, the only possible value is 9 and 0. But they have told us that all the digits are non-zero. So this case is not valid at all. T is equal to 1 will not give us any answer. What about 2 is equal to 2? When t is equal to 2, r minus s will be equal to 20p minus 28. Okay. So now again, for the same reason that I told you that p cannot be more than 1, here p has to be 1. When p is 1, the difference is minus 8. Then what can be the values of r and s that such that they give you this difference of minus 8? One possible value is 1 and 9. Okay. And 2, so that is the only possibility. But we need to assume that p is equal to 1 and r is equal to 1. But they have told us that all the digits are distinct. So this is also rolled out. This does not give us any answer. We have two more cases to find. T is equal to 4. When t is equal to 4, r minus s will be 20p minus 26, because 4 minus 30 will give you minus 26. When again p has to be 1, so this has to be minus 6. Which values will give you minus 6? One is 1, 7, 2, 8 and 3, 9. Now this 1, 7 and 3, 9 are rolled out, because we have assumed that p is 1 and q is they have given us that q is 3. So these two conditions are rolled out. Okay. So t equals 2 will give us how many values for r and s? Only one value. We have one last condition to check, that is t is equal to 5. When t is equal to 5, r minus s is equal to 20p minus 25, because 5 minus 30 will give us minus 25. So 20p minus 25. Again p is equal to 1, so this will have to be equal to minus 5. Which values will give you minus 5? The values will be 1 and 6, 2 and 7, 3 and 8 and 4 and 9. So 3 and 8 and 1 by 6 they are ruled out, because we have assumed that p is 1 and they have already told us that q is 3. So 2 and 7 they were possible, 4 and 9 they are also possible. So how many different sets of r, s can be there? 3 sets, 2, 8, 4, 9, 2, 7. So the answer to this question will be option B, 3. Okay, we'll go further now. Question 35. Okay, what is the maximum value of n such that 3 into 7 into 343 into 385 into 1000 into 240 into 7777 is divisible by 35 raised to n. Now, what they are asking us is this entire product, it has to be divisible by 35 raised to n. What is 35? 35 is nothing but 7 into 5. So, 35 raised to n, it is nothing but 7 raised to n into 5 raised to n. Okay. Now, when they tell us that this has to be divisible by 35 raised to n, it means that we need to have these many numbers of 7s and 5s here. So, among these, we just need to see how many 7s and 5s are there. Okay. Okay. So, we will count the number of 7s first. How many 7s are there here? 1. How many 7s are there here? 343, it is nothing but 7 cube. So, there are 3 7s here. 3. What about 385? Now, 385, let us try and divide it by 7. 7 5s are 35 and 7 5s are again 35. So, there is no 7 in 55. So, how many 7s are there in 385? That is 1. What about 1000? There is no 7 in 1000. What about 2401? Let us try and divide. 2401. 7 3s are 21. 3 0. 7 4s are 28. 2 1. So, 7 3s are 21. So, when you divide 2401 by 7, we get 343, and we know that 343 is 7 cube. So, 2401, what is it? It is 7 to the power of 4. So, how many 4s are there here? We have 4. What about 77777? Again, let's just divide it by 7. If we divide it by 7, we get 11111. And is 1111 divisible by 7? No. Why? Because one of the divisibility rules of 7 is, if you can divide these sets of 3 digits, 111 and 11, the difference is 100. 100 is not divisible by 7. So, this is also not divisible by 7. So, how many 7s do we have here? Only 1. So, in entire this expression, how many 7s are there? 1 plus 3 is 4. 4 plus 1 is 5. 5 plus 5 is 10. So, we have totally 10 7s here, but we do not have 10 options. So, now we will calculate how many 5s are there. No 5, no 5. Here we have only 1 5. And here this is 125 into 8. So, 125 is 5 cube. So, here we have 3 these things. Okay. Okay. So, how many, here there is no 5, here there is no 5. So, how many 5s are there in this total? There are only 4 5s. So, we have 10 7s, but only 4 5s. So, what will be our answer? Our answer will be 4. Why not 10? Because we want such a number, that is, this can be 7 to the power of 4 into 5 to the power of 4. But it cannot be 7 to the power of 10 into 5 to the power of 10, because if you try to divide it by 7 to the power of 10 into 10 to the power of 5 to the power of 10, you will not get, it will not be correctly entirely divisible. So, but this, it will be divisible by this one. So, the answer to this question is option B, 4. Okay, we will go next now. 37. Okay. Now, P and Q walk along a circular track. They start at 5 am from the same point in opposite directions. Okay. P walks at an average speed of 5 rounds per hour and Q walks an average speed of 3 rounds per hour. How many times will they cross each other between 5:20 and 7? Now, here they have not asked us between 5 and 7. They have asked us for the number of times they cross each other between 5:20 and 7. Okay. So, how to answer this question? Now, actually, what we can do, what we need to do is, we need to see how many times they cross each other between 5 and 7. Okay. And then we need to see how many times they cross each other between 5 and 5:20 and take the difference of them. Okay. Okay. Now, how many times will they cross each other between 5 and 7? They started together at 5 o'clock, we know that. Between 5 and 7, what we need to do is take their relative speed. What is their relative speed? Now, they walk in different directions. One walks in one way and the another walks in different way. So, when that is the case, as per the relative speed concept, we need to add their speeds. So this is 5 rounds per hour and this is 3 rounds per hour. So together they will make up how much? Their speed will be 8 rounds per hour. Okay. So distance is given by speed into time. So what is the speed? Speed is 8. What is the time? It is 2 hours. So together how many times do they cross each other? Between 5 p.m. and 7, it is 16 times. Okay, so 16 times they cross each other given during this time. What about between 5 and 5:20? Between 5 and 5:20, again we will apply the same formula. The speed is 8 rounds per hour, but what is time? 20 minutes. 20 minutes is 1 by 3 hours. So this is 1 by 3. What is 8 into 1 by 3? It is 2.67. Okay, so it means that they have not crossed each other 3 times, but they have crossed each other 2 times, but they are about to do the third time. They have not yet done it. But in 2 hours they do 16 times. So it means that between 5 and 5:20 they cross each other only 2 times. Okay. Okay. One other thing. Why did I take 16 this thing here? For that is when the distance between them makes a 1 or a multiple of 1, they meet each other. That is the concept of circular this thing. Since this is just PYQ solving, I am skipping all those basics. Okay. Now this thing, between 5 and 7 they cross each other 16 times, and between 5 and 5:20 they cross each other only 2 times. Whenever you get a decimal, just take the natural number before that. So 2 times. So how many times they cross each other between 5:20 and 7? That is 16 minus 2, that is 14. Okay. Okay, I can explain this in a better way if you did not understand it. Okay. Let us assume that the circumference of the circular park is 1 kilometer, 1000 meters. Okay. Now what happens is, the first person's speed, it is how much? 5 rounds per hour. When they say 5 rounds per hour, it means that 5 kilometers per hour or 5000 meters per hour. Let us talk about kilometers. 5 kilometers per hour. The second person's speed is 3 kilometers per hour. When they are moving in opposite directions, their relative speed will be 8 kilometers per hour. So it means that for every 1 hour, the relative distance between them will be 8 kilometers. Whenever the relative distance between them is 1 kilometer, they will meet. When the relative distance is 1 kilometer, they will meet. When the relative distance is 2 kilometers, they will meet. Because whenever the distance between them on one side is 1 kilometer, the other side they are meeting. So that way, for each 1 hour, they will meet 8 times. For 2 hours, they will meet how many times? 16 times. So that we got. Between 5 and 7, how many times they meet? Between 5 and 7, 16 times they meet. What about between 5 and 5:20? So we know that 5 and 5:20, it is nothing but 1/3 of an hour. So for 1 hour they are meeting 8 times. For 1/3 of an hour, 8 divided by 3, 2.6. So 2.6, it means that they have crossed, the relative speed between them is 2667 meters. So for when the relative distance between them was 1000 meters, they met. When the relative speed between them was 2000 meters, they met. But here it is 2667. If they further walked for 333 meters, they would meet. But they have not yet walked. So between 5 and 5:20, how many times they meet? Only 2 times. So but we know that 5 to 7 they meet 16 times. But here they meet only 2 times. So the rest of the 14 times, when do they meet? Between 5:20 and 7. So the answer to this question will be 14. Option C. Okay, we'll go further now. Question 39. Okay. A tram overtakes 2 persons, X and Y, walking at an average speed of 3 km per hour and 4 km per hour in the same direction, and completely passes them in 8 seconds and 9 seconds respectively. What is the length of the tram? Now, again, this is the relative speed concept. Whenever in the previous question they were walking in opposite directions, so we added their speeds. When they are walking in the same direction, we will subtract their speeds. Let the speed of the tram be S. Okay. So length of the tram is given by using this formula, d is equal to st. This will become length into speed into time in this case. So what is the relative speed? the length of the tram will remain L. So the speed of the tram is S, then the relative speed will be S minus 3. Okay, and how many seconds? 8 seconds. But this 3 km per hour, it is in kilometer per hour. So how to convert kilometer per hour into meter per second? Just multiply it by 5 by 18. Okay, into time is 8 seconds. Now we have expressed everything in seconds, meters and seconds. So there is no conflict of these things here, units here. This is with respect to person X. With respect to person Y, the relative speed is S minus 4 into 5 by 18. How many seconds? 9 seconds. Okay. Take a look at the problem statement and take a look at the given equation. Now L and L, they are same. We can equate S and RHS and RHS. So S minus 3, 5 divided by 18, 8 is equal to S minus 4, 5 divided by 18, 9. 5 by 18, 5 by 18, we can cancel them. So 8S minus 24 is equal to 9S minus 36. If you can send 8 there, 12 is equal to S. So what is the speed? It is 12 km per hour. If you just substitute in any of this equations, we will get the length of the tram. So we will substitute in the first equation. So L is equal to 12 minus 3 is 9. 9 into 5 by 18 into 8. So 9 divides 18, 9 2s are 8, and 2 divides 8, 2 4s are this thing. So we have 5 into 4, 5 into 4 is nothing but 20 meters. So what is the length of the tram? It is 20 meters, that is option C. Okay, we will go further now. Question number 40. Now, n square is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1. Then how many digits does the number n have? How to answer this question? This is easy. Now what is 11 square? 11 square is 121. What is 11 cube? 11 cube is, sorry, not 11 cube, sorry, 111 into 111 square. 11 cube is 1, 2, 3, 2, 1. How? See here, 111 into 111. This will be 111 plus 111 plus 111. This will be 1, 2, 3, 2, 1. Correct. So this such a number 1, 2, 3, 4, 5, 6, 7, 8, 9, that is consecutive digits in ascending order and then consecutive digits in descending order. You get such a number only when you sorry, this is square. Only when you multiply a number which has only one digit, all the digits of that number is 1, and you have squared it. Okay. So what about 1, 1, 1, 1 square? This will be 1, 2, 3, 4, 3, 2, 1. How? See here, 1, 1, 1, 1 into 1, 1, 1, 1. This will give you 1, 1, 1, 1 plus 1, 1, 1, 1 plus 1, 1, 1, 1 plus 1, 1, 1, 1. This will give you how much? 1, 2, 3, 4, 3, 2, 1. Okay. So how many these things? How many digits are there in that number? That is the biggest digit in their square. Here there are 2 digits. The biggest digit is 2. Here there are 3 digits. The biggest digit is 3. Here there are 4 digits. So the biggest digit is 4. That way, what is the biggest digit here? It is 9. It means that it is nothing but, this is nothing but this square. How much is it? Thousands, like 11 crore, 11 lakh, 11,000, 111. So how many digits are there? 9 digits are there, because the biggest digit here is 9. So the answer to this question will be how much? Option D, 11. Going further, question number 45. Okay. A set X of 20 pipes can fill 70% of a tank in 14 minutes. Another set Y of 10 pipes fills 3/8 of the tank in 6 minutes. A third set Z of 16 pipes can empty half the tank in 20 minutes. Okay. So there, until now, we had dealt with what kind of pipes and cistern problems. There was a tap or there was a pipe, it would fill the tank. There was another pipe, it would also fill the tank, but there would be a third type, it should drain the tank. But here there are 20 X type of pipes which are filling the tank. Then there are 10 Y type of pipes, they are also filling the tank. And then there are 16 Z type of pipes which drain the tank. Now they have given us the time taken by each of them to do that. Now let us talk about these 20X pipes. 20X pipes, they fill 70%. 70% is 70 by 100, that is 7 by 10. That is, they fill 7 by 10th of the tank in 14 minutes. So when they fill, okay, no, let us read the problem further. It will help us, I will tell you why. If half of the pipes of set X are closed and only half of the pipes of set Y are open, and all pipes of Z are open, then how long will it take to fill 50% of the tank? So now they have given us some data, and based on that, half of the X pipes are closed. There are 20 pipes, so half of that would be 10 pipes. Then only half of the pipes of Y are open. So again, Y are 10 pipes, half of that is 5 pipes. When they say 5 are open, 5 are open. And all the pipes of Z, that is all the 16 Z are open. Okay, now we will represent it in mathematical form. 20X pipes will fill 7/10 of the tank in 14 minutes. So in one of the previous problems I have told you, how to calculate the time taken by 20X pipes to fill the complete tank. Just inverse this fraction and multiply it here. That is 20X, these things will take 14 into 10 by 7. What is 14 into 10 by 7? Now 7 will divide 14. So 7 2s are 14. So 2 into 10, that is 20 minutes. So it means that 20X pipes will take 20 minutes to fill the complete tank. Now, but what are they asking us about? If half of the set X are closed, now 20 pipes will take 20 minutes. If you close half of them, you are only left with 10X. If 20 pipes can fill the tank in 20 minutes and only half of it are let open, then they will take double the time. That is 10X pipes will take 40 minutes. This is first step. This is just simple. If two men can do a work in one day, if you put only one person to work, he will take twice the number of days, 2 days. That way, if 20 pipes can do the work in 20 minutes, if 20 pipes can fill the tank in 20 minutes, half of that, it is 10 pipes can fill the tank in 40 minutes. Then, what about Y? Now, 10 Y pipes can fill 3/8 of the tank in 6 minutes. Okay, what about 10 Y taps to fill complete tank? Just inverse this fraction, 3/8, 8/3 and multiply it here. So 8 by 3 into 6. 3 will divide 6, that is 8 into 2. 8 into 2 will give you 16 minutes. Okay, so 10 Y taps will take 16 minutes to fill the tank, but they have told us that only half of those these things are let open, half of them are closed. So only if you put only 5 of these things to work, they will take double the time, so they will take 32 minutes. Done. Now about Z. 16 pipes of Z can empty the tank in 20 minutes. There is no complication there. 16 Z pipes, they take 20 minutes to drain the, not complete data. 16 Z pipes, they will take how much time to fill half of the tank? They take 20 minutes to drain half of the tank. Okay, so how much time will they take to drain complete tank? Just inverse this fraction and multiply it here. 20 into 2 is 40 minutes. Okay. Now these are the players that are in play. 10 pipes of type X that take 40 minutes to fill the tank. Then 5 types of set Y which take 32 minutes to fill the tank. Then 16 16 type of Z pipes, they take 40 minutes to drain the tank. Now if you see here, this and this, they take same time. It means that these take 40 minutes to fill it and these take 40 minutes to drain it. They will anyway cancel each other's effect. Okay, so the only thing that effectively does any work is these 5Y, these things. So 5 pipes of Y type are open, they will take 32 minutes to fill the tank, but they want us to calculate how long will it take to fill 50% of the tank. Now to fill 100% of the tank, it takes 32 minutes. To fill half of it, it will take only 16 minutes. So do we have that option? Yes, option D, 16 minutes is our answer. Okay, we'll go further now. Question 46. Okay, if n is a natural number, then what is the number of distinct remainders of 1 raised to n plus 2 raised to n when divided by 4? Okay, now n is a natural number. Okay, now 1 to the power of natural number plus 2 to the power of natural number, it will also be a natural number. Okay, now given any natural number, when you divide it by 4, there are only 4 remainder possibilities: 0, 1, 2, 3. When you divide any natural number by 4, these are the only 4 possible remainders. Correct. Okay, now 2 raised to n plus 1 raised to n. 2 raised to n plus 1 raised to n, is it a multiple of this entire expression? Is it a multiple of 2? No, because this is a multiple of 2 and this is not a this is a 1 raised to anything is 1. So even number plus 1 will give you odd number. So the only these things that you cannot get, the only values which you cannot get with 1 raised to n plus 2 raised to n is, you cannot get either a 0 or a 2, because 2 raised to n is a multiple of 2, and when you add plus 1 to it, it is no longer a multiple of 2. So you do not get either 0 or 2 as remainders. So the only remainders possible are 1 and 3. Let us see, if n is equal to 1, then this will be 2 plus 1 is equal to 3. Okay, this is the case. If n is equal to 2, then 4 plus 1 is equal to 5, and if we divide 5 by 4, we get a remainder 1. Okay, here the remainder will be 3, here the remainder will be 1. So these are the only 2 possible things. We cannot get 2 or 0 at all. We cannot get 2 or 0 at all. So how many, what is the number of distinct remainders? The answer is 2 distinct remainders. The answer is option C. Okay. Question 47. Let P equal QQQ be a 3-digit number. What is the HCF of P and 481? Now, in one of the previous problems, I told you that 1001 is one of the favorite numbers of UPSC CSAT paper, where it is given by this product. Similarly, another favorite number of UPSC CSAT paper setters is this number 111, which is a multiple of 37 and which is a product of 37 and 3. Now this question is based on this concept. 111 is a multiple of 37 to 3. So when they tell us that it is QQQ, it can be either 111 or 222 or 333 or 444, that way up to 999. Whatever it be, it will be a multiple of 111. Okay. So this P, it will be a multiple of 37 as well as 3 and some other number. Okay. Then what about 481? 481, if you see closely, 481 is 370 plus 111, because then you will get 481. Okay, what is 370? 370 is 37 into 10 and 111 is 37 into 3. So if you can take 37 common, 37 into 13. So 481 is nothing but 37 into 13. And P will always have a factor of 37. and 481 has a factor 37. So what is the HCF of P and 481? It is nothing but 37. So option C is your answer. Okay. For example, let Q be 1, then 111 is given by 37 into 3. What is the HCF of 481 and 111? It is 37. Done? Okay. We'll go further now. What is the 489th digit in the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and go on, so on. So what they have done is they have just written each number 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 0 that is 10, 1, 1 that is 11, 1, 2 that is 12, then 13, 14, 15, that way they will go on. They want us to find what is the 489th digit. Okay, how to calculate the 489th digit. Even though it seems complicated, it is not so complicated at all. Now, from let us talk about 1-digit numbers, 2-digit numbers and 3-digit numbers individually. Then let us see. Then from 1 to 9, how many digits do we have? We have 9 digits. From 1 to 9, we have 9 digits. What about from 10 to 99? 10 to 99, we have how many numbers? 10 to 99, we have 90 numbers and each of those numbers has 2 digits. So 90 into 2, that is 180 digits are over here. Okay. Then 100 to 199. 100 to 199, how many numbers do we have? We have 100 numbers, each of 3 digits. So from 100 to 199, how many digits do we get? We get 100 into 3, that is 300 digits. If you add them, 9, 8, 4. So if you write from 1, 2, 3, 4, 5, 6, 7, 8 and till 197, 198 and 199, then you have finished up all your 489th letters. So what is the last number that we used? 199. And what is its last digit? It is 9. So the 489th digit of this entire number would be 9. That is option D. Okay, we'll go further now. Okay, here. The 5-digit number PQRST, all distinct digits, is such that T is not equal to 0, P is thrice T, S is greater than Q by 4, while Q is greater than R by 3. How many such 5-digit numbers are possible? Okay. Now the number is in the format PQRST. Okay, T is not equal to 0. P is thrice T. Now when they tell us that P is thrice T, the only possible values that T can take is only 1, 2 and 3, because when it is 1 this will be 3, when it is 2 this will be 6, and when this is 3 this will be 9. If it happens to be 4, then P has to be 12, but P is a single digit, it cannot be 12. So these are the possible values for T and P. Now let us talk about Q. They tell us that S is greater than Q by 4 and R is greater than R by Q is greater than R by 3. It means that Q is equal to R plus 3. Then S is greater than Q by 4. So S is equal to Q plus 4. When S is equal to Q plus 4, we already know that S is equal to R plus 3. So S is equal to R plus 7. That is Q plus 4. In place of Q, we will write R plus 3. R plus 3 plus 4 is R plus 7. So now, what are the possible values for R? R can take the values starting from 2, 3, I think 2, 3, okay. It cannot take the value of 1 because all of them are distinct. So T has already taken, no, it can take values, sorry. We will evaluate individual cases. R can take the value 1 and 2. It can also take 0. Only T cannot be 0. So R can be 0, R can be 1, R can be 2. Okay. Now when R is 0, Q will be 3 and S will be 7. And when R is 1, Q will be 4 and S will be 8. When R is 2, Q will be 5 and S will be 9. So R cannot be 3 because if it happens to be 3, then S has to be 10, but 10 is not single digit. So these are all the possible cases. Now we need to match these things. When T is 1, how many possibilities are possible? This is not a possible case when T is 1 because P and Q, they will repeat 3. So that is not possible. And 418 is not possible because 1 and 1 will repeat. 5 to 9 is possible, because then 3, 5, 2, 9, 1 is possible. So when t is 1, we have one possible number. Then when t is 2, 307 is possible, and 418, that is also possible, but 5 to 9 is not possible because 2 will be repeated. So when t is 2, how many possibilities are there? 2 possibilities we have. What about this thing 3? When t is 3, 307 is not possible because 3 will be repeated. Then 418 is possible, and 5 to 9 is not possible because 9 would be repeated. So only one possibility is there when t is equal to 3. So totally how many possibilities are there? 1 plus 2 plus 1, that is this number PQRST can have totally 4 different values. Do we have that option? Yes. Option B, 4 is the answer. Okay, we'll go further now. 59th. Okay. X can complete 1/3 of a certain work in 6 days. Y can complete 1/3 of same work in 8 days, and Z can complete 3/4 of the same work in 12 days. All of them work together for n days, and then X and Z quit. Y alone finishes the remaining work in 8 2/3 days. What is n equal to? Okay, so let us see. Now X does 1/3 of the work in how many days? 6 days. So it from one of the previous problem, we already know that when X does 1/3 of the work in 6 days, just inverse this fraction and multiply it here. That will give you the time taken by X to do the complete work. So 6 into 3 is 18 days. X take how many days? 18 days. What about Y? Y can do 1/3 of the work in 8 days. So to do the complete work, Y will take 8 into 3 is 24 days. Then Z can do 3/4 of the work in 12 days. So to do the complete work, he will take 12 divided by 3 is 4. 4 4s are 16 days. Okay. So X take 18 days, Y takes 24 days, and Z takes 16 days to do the complete work. Now we will use the LCM method. So what is the LCM of 18, 24 and 16? It is 144. It is how much? It is 144. So let us assume that the work to be done it can be broken up into units, and it can how many units of work are there? There are 144 units of work. Whatever the work be, we will assume that there are 144 units of work to be done. When that is the case, how long will each of them take to do the work? Sorry, how much of units of work will do each of them for a day? Now X takes 18 days to do 144 units of work. So how much of units of work will he do per day? 144 divided by 18, that will be 72 by 9 is 8. So he does 8 units of work per day. What about Y? 144 by 24, he does 6 units of work per day. What about Z? He does 9 units of work per day. Okay, then we know that Y alone finishes the remaining work in 8 2/3 days. So what is the speed of Y? The speed of Y is 6 units per day. So with that speed, he works for 8 2/3 days. What is 8 2/3? If you convert it into improper fraction, it is 26/3. Okay, so he takes 26/3 days. So how many units of work does he do? 3 2s are 6. 2 into 26 is 52 units of work is finished by him in the last 8 2/3 days. It means that out of 144, 52 units of work are done by Y alone. So together how much work did they do? 144 minus 52. That is how much of work they did. 144 minus 52, that will be 92. Okay. So 92 units of work they did together. But when they were working together, what was the work being done per day? 8 plus 6 is 14. 14 plus 9 is 23. So they would do 23 units of work per day. And how long did they? And they completed 92 units of work. So how many days did they work together for? They worked together for 4 days. Because 23 units of work was being done per day, and if for 4 days 23 into 4, that will give you 92 units of work. So what is the value of n here? Sorry, n, that is 4. Option B, 4. Okay, we'll go further now. What is the remainder when n raised to 3 plus n raised to 4, n to the power of 5, n power of 6, that way up to n to the power of 100 is divided by 6. Now this n to the power of something, it is each term, it is divisible by 3, right? Because you are raising 9 to something. So when you raise 9 to something, the resultant will be a product of 9. Hence, if it is divisible by 9, it is also divisible by 3. So all these individual terms, they are divisible by 3. So when you add multiples of 3, their sum together, it also has to be divisible by 3. So this term, it is divisible by 3. Done. Next, is each term odd or even? Now you are raising an odd number to some power. When you raise an odd number to any power, the resultant will always be odd. Okay. So 9 raised to 3 is odd, 9 raised to 4 is odd, 9 raised to 5 is odd. That way 9 raised to 100, that will also be odd. Okay. Now how many odd terms are there? Now 3 to 100, so together there are 98 terms. So you are adding 98 odd numbers. When you add an even number of odd numbers, the resultant will be even. For example, 1 plus 1 will give you 2, but 1 plus 1 plus 1 will give you 3, odd number. But 1 plus 1 plus 1 plus 1, that is 4 number of odd numbers, they will give you again 4, that is even number. So this entire expression, it is even number, so it is divisible by 2. So this expression, it is divisible by 3 as well as 2, so it has to be divisible by 6. So what is the remainder when it is divided by 6? The answer is 0, because it is divisible by 6, it leaves no remainder. So the answer to this question is option A, 0. Okay, we'll go further. Okay, a question is given followed by 2 statements, 1 and 2. Consider the question and the statements and mark the correct option. Okay. Now, what is the smallest 1-digit number having exactly 4 distinct factors? Now, what is the smallest 1-digit number? Now, let us try to answer it. Now, 0 can have any number of factors, so we cannot count it. What about 1? 1 has only 1 factor. What about 2? 2 has 2 factors. What about 3? 3 also has only 2 factors. What about 4? 4 has 3 factors, 1, 2 and 4. What about 5? 5 has only 2 factors. What about 6? 6 has 1, 2, 3 and 6. So 6 has 4 distinct factors. So 6 is the smallest 1-digit number having 4 distinct factors. Now statement 1, 2 is one of the factors, yes. 3 is one of the factors, yes. But we were able to answer this question without using the statements. So the question can be answered even without using any of the statements. Option D, that will be our answer. Okay, we'll go further now. 69. Okay, question, similar type of question. Let P, Q, R, S be distinct non-zero digits. Okay, if PP into PQ is equal to RR, SS, where P is less than or equal to 3 and Q is less than or equal to 4, then what is Q equal to? Okay, so R is equal to 1, S is equal to 2. Let us see. Let us try to answer the question without statements first, then we will see which statements we are required to answer the question. Now PP into PQ is equal to RRSS. Okay, PP into PQ, it is equal to RRSS. Okay, where P is less than or equal to 3. So P can have the values 1, 2, 3. Q is less than or equal to 4. So Q can have the values 1, 2, 3, 4. Let us try 1 for P. Now when P is 1, let us try 1 for, they are non-zero distinct digits. So Q cannot be 1, Q can be 2. What is 11 into 12? It is 132, and 132 is not 4-digit number. We want 4-digit number. So P is equal to 1, Q is equal to 2, that did not work out. Let us try P is equal to 1 and Q is equal to 3. This is also 143, 3-digit number, not possible. Okay, then let us try 11 into 14. This is a 154, 3-digit number. So P is equal to 1 is not a valid case at all. Okay, done. Then let us try P is equal to 2. 22 into, let us say Q is 1. 22 into 21. Now 22 into 21, we know that 21 square is a 441 and 22 square it must be 484. So 22 into 21, it has to be 3-digit number. So this is not a valid case. Now let us try 22 into 23. Again, 22 square is 484 or something. So this is also 3-digit number, not possible. Now 22 into 24. So we know that 25 square itself is 625, 3-digit number. So this is also a 3-digit number. So P is equal to 2 is not a valid case again. So let us try P is equal to 3. 33 into, let us try 31. 33 into 31 will give us what value? Now, 1 3s are 3. 1 3s are 3 plus 99. This will give us 2. 1023. 33 into 31 gives us 1023, but it is not in the format RRSS. So 33 into 31 is not possible. Okay. Now let us try 33 into 32. That is, we assume that P is 3 and Q is 2. 33 into 32 will give us 6, 6, 9, 9, 6, 5, 1, 0, 5, 6. So that is not in the format of RRSS. So this is also not possible. Now Q cannot be 3. So we are left with 33 into 34. 12, 13 plus 99. 2, 1 carry, 3, 1 carry. Okay, let us add them. 2, 9 plus 3 is 2, 1 carry, 10, 11. So 33 into 34 will give us 1122. Now that is in the format of RRSS. Now P is 3 and Q is 4, R is 1 and S is 2. So we were able to uniquely identify the values of P, Q, R and S. Then what is Q equal to? Q is equal to 4, okay, without any other overlapping. So now we were able to answer this question, and we ourselves got that R is equal to 1, S is equal to 2 without using statements. So we can answer this question without using any statements. Do we have such an option? The question can be answered even without using any of the statements. Yes, option D, that is our answer. Okay, we'll go further now. 74th. Okay, a question is given followed by two statements, 1 and 2. Consider the question and the statements and mark the correct option. Is P plus Q whole square minus 4PQ, where P, Q are natural numbers, positive? Statement 1, P is less than Q. Statement 2, P is greater than Q. Okay, let us see. Now P plus Q whole square minus 4PQ. It is an identity, right? A plus B whole square is A square plus 2AB plus B square. So this will be P square plus Q square plus 2PQ, sorry, 2PQ and 2QP, don't matter, minus 4PQ. Now this will be P square plus Q square, 2PQ minus 4PQ, it will be minus 2PQ. And again, this matches what? It matches A minus B whole square is equal to A square plus B square minus 2AB. So this is P minus Q whole square. P minus Q whole square. Okay. P minus Q or whole square or Q minus P whole square. No difference between them. Okay. Now this is the given expression actually. Now is this positive or is this negative? When something is squared, the sign will always be positive. So is P plus Q whole square minus 4PQ, where P and Q are natural numbers, positive? Yes, but there is an exception. When P is equal to Q, they have not told us that P and Q are distinct. If P is equal to Q, then P minus Q whole square will be 0. But 0 is not a positive number. It is neither negative nor positive. So the only exception is P is equal to Q. When they tell us that P is less than Q, then this expression is positive. When they tell us that P is greater than Q, then also this expression is positive. But when P is neither greater than nor less than Q, then P is equal to Q. In such case, this expression will be 0, which is not positive. It is not necessarily negative. It is neither positive nor negative. So these statements, they are required to make this expression positive. Let us see which option matches that. Question A can be answered using any of the statements alone, but cannot be answered using the other statement alone. No. Can be answered using either statement alone. Yes. Can be answered by using both statements together. No. Can be answered even without using it. No. So the answer to this question will be option B. The question can be answered by using either statement alone. So the answer to this question is option B. Okay. We'll go further now. 75. In a T20 cricket match, 3 players X, Y and Z scored a total of 37 runs. The ratio of the numbers of runs scored by X to the number of runs scored by Y is equal to the ratio of number of runs scored by Y to the number of runs scored by Z. Value 1 X, value 2 Y, value 3 Z. We need to find the relationship between them. So what they have told us is X by Y, it is equal to Y by Z. Okay. So if you just do cross multiplication, X Z is equal to Y square. Now based on this information, we can say that Y is the middle number, that is either this is true, X is greater than, Y is greater than Z, or X is greater than less than, Z is less than, Y is less than Z. Either of these are true, but we cannot say which of them are this thing. We can only say Y is the middle term, but we cannot say which is the greatest term number or which is the smallest number. There is no distinction between X and Y here. Correct. So when they tell us the ratio, they have not told us if it will be a proper fraction or an improper fraction. So that way, even though they have told us that the total runs is 37, it does not matter to us. So this question cannot be answered at all. So the answer to this question will be option D, cannot be determined due to insufficient data. Okay, we'll go further now. Okay, let X be a real number between 0 and 1. Which of the following statements is / are correct? X square is greater than X cube and X is greater than square root of X. Now if you take X to X can be anything like 0.1, 0.5, anything, but if you consider such a value, it gets bit difficult to think about these expressions. So what we can do is, we shall think of X as X is equal to 1 by n. For example, it can be 1 by 2 or 1 by 3 or 1 by 4 or so on. So when it is 1 by something, anything, it will be less than 1, but it will be greater than 0. So then that satisfies between 0 and 1. Now X, let us start with this one, 1 by 2. Now when X is equal to 1 by 2, X square will be 1 by 4. Now which one is greater? X is actually greater. X cube will be 1 by 8. Out of these two, which one is greater? X square is greater. So X square, it is greater than X cube. So statement 1 is correct. What about statement 2? Now again we will begin here. What is a square root of X? Square root of X will be 1 divided by square root of 2. Now which one is bigger? 1 by square root of 2 is bigger. Why? Because square root of 2 is lesser than 2. When you have lesser number in denominator, the whole number, the value of the number will increase. This is the value of square root of 2 is 1 by 1.4 something. So 1 by 2 and 1.4, 1 by 2 is the lesser number and 1 by 1.4 is the greater number. So X is actually lesser than square root of X. But this says X is greater than square root of X, so this is wrong. So only statement 1 is correct. So the answer to this question will be option A, 1 only. Okay, we'll go to the last question now. Okay, done. No, we are done with all the mathematics questions here. Okay, So mathematics questions, they were, as I said, the difficulty level was from moderate to difficult. But reasoning, they were from easy to moderate, and even some of them, they were difficult. And reading comprehension questions, they were really difficult this year. Okay. This is all about quant questions, that is mathematics questions. Thank you.